Okay, we're going to talk about rotations. So it's just like what it sounds and what you could see on this picture. You're rotating. On this picture, the bottom rotations has actually been rotated 90 degrees. So this is just a little graphic of showing you a 90-degree rotation. And this is algebraically how it changes. It goes from x, y. You flip the x and the y numbers, and the x becomes negative. 180-degree rotation, the x and the y stay the same, but they both are multiplied by a -1. And then 270 goes almost all the way around. 360 would be all the way around. A 270, you flip the x and the y numbers and multiply the y times -1. Okay, now we're going to do an example rotating 90 degrees, and we're doing all of these clockwise. We'll learn counterclockwise later. So A is at 2, 1. That's A. B is at 1, 2, 3, 2, 3, 4. That's B. And C is at 4, 2. Oops. Don't need that. Okay. And we're going to go 90 degrees clockwise. So what we learned, it's going to go x, comma, y. And then we switch the x and the y numbers, and the x number is multiplied by -1. So we have A is at 2, 1. B is at 3, 4. And C is at 4, 2. A prime, the 1's going to go first. We're going to switch 1 and 2. And the 2 we're going to multiply by -1. B, we're going to switch the 4 and the 3. The 3 multiplies by -1. And C, switch the 2 and the 4 is multiplied by -1. So our new figure will be 1, -2, A, then 4, -3, it's B prime, and then 2, -4, C prime. And notice it's the exact same figure. And if we draw A to the origin and then back, that forms a 90-degree angle. And that's why it's a 90-degree rotation, because it went 90 degrees. Okay, this next one we're going to actually use the exact same figure as the last one. So 2, 1, 3, 4, and 4, 2. It's A, B, C. But this time we're going to go 180 degrees. So algebraically, that's x, comma, y. The x and the y stay, but they become negative. You multiply them by -1. So A was 2, 1. B, 3, 4. C, 4, 2. A prime becomes -2, -1. We're just multiplying all of the numbers by -1. So -3, -4. And C becomes -4, -2. So if we graph the translation, it would be -2, or the rotation, -2, -1, A prime, -3, -4, B prime, and -4, -2, C prime. And we draw a line from A to the origin and then the origin to the new A, notice that that is a 180-degree rotation. Or if you had looked at it this way, because I guess that way would technically be clockwise, looking at it this way. So that would be a 180-degree rotation. All we did was multiply all the numbers by -1. They didn't flip. Okay, on this one, we're going to rotate it 270 degrees. So 270 degrees algebraically looks like x comma y. And then the x and the y switch, but y is multiplied by -1. 90 degrees, the x was multiplied by -1. So we have x, 3, -1, y, 5, -4, and z, 1, -5. Go ahead and graph that. 3, -1, 4, 5, -4, 5, 1, 2, 4, and then 1, -5, z, x, and y. Now we're going to switch those so that x is second and x does not change. So let's go ahead and write all the x's second. And then the y's these are all the y's, and they are all multiplied by -1. So -1 times -1 is 1. -4 times -1 is 4. 5 times -1 is 5. So go over 1, up 1, 2, 3. That's x. 4 up 5. That's y. And 5 up 1 is z. And if we draw a line from x to the origin and x to the other x, now we can look at that as a 90-degree angle. That would be a clockwise though, because these are all new ones. The purple is the new. So we're going from the blue one to the purple one. That's a 270-degree clockwise rotation, or a 90-degree counterclockwise. That would be this way. Would be counterclockwise. That would be 90 degrees. So 270 clockwise. I'll write that in green. 270-degree clockwise is the same as a 90-degree counterclockwise. Sorry, clockwise. Okay, so we can see the green is a 270 clockwise, and the red is 90-degree counterclockwise because we're going backwards. If you're reading a clock, you'd be reading it backwards, but they're the exact same rotation. And algebraically, that's how it is.